You'll notice pre-calc kids, it's 349, 350. That's how important I feel this is. All right, so the first question on your challenge exam is going to be like super easy. Solve this equation. I mean, it's just the distributive property. Now, what'll get y'all is you'll try to do it in your head. That's what'll get you. You'll make sign mistakes in your head. So I did the distributive property, like you're supposed to. I'll combine some like terms. 5 and 2x is 5x. Let's say we have a -2 and a -15, which is -17. And we're going to take away 8, which is -25, and we're still equal to 7x. Now 7 minus 5 is 2, so 7x minus 5x is 2x, and then we'll divide out the 2. You have 25 halves as my x value. You're not going to be allowed to use a TI-84 on these, okay? All right, solve the equation 5x squared minus 18x plus 8. Obviously, you're going to have to take this thing and set it equal to 0. So you're going to jump everything around. And I don't know if this thing factors or not, but we're going to use a quadratic formula. And I'm not at work right now, so I can't use my stylus. This is going to look really, really bad. It's going to be x equals -b plus or minus square root b squared minus 4ac all over 2a. All right, so we have it here. We have a negative times a negative, which is a positive. We have 4 times 5, which is 20, times 8, which is 160. We have 25. Boy, that looks bad. Using my thumb to draw, it looks really, really bad. So we have x equals -18 plus or minus the root of 185, both pieces over a 10. Thing is hideous looking, isn't it? Absolutely hideous. All right, so root 185 would be 5 times 37. There's not anything you're going to do with it. About the only thing you can do is you can reduce this. Those are both even. That's -9/5 plus or minus root 185. Both pieces sitting pretty over 10. Ta-ta! Find all the zeros of this function, and you're not going to like this. This is on your challenge exam, and it is old school, guess and check, lots of synthetic division. And we have a list of potential zeros by finding the factors of the constant, which is -45, which is 45. And it's going to be sitting over the factors of a, which is 1. So factors of 45 is a pretty long list. It's 1, 3, 5, 9, 15, 45. That's your list of factors. And don't forget the plus or minus symbol. This is going to be fun without a stylus, isn't it? All right. So I'm going to just make some guesses. I'm going to say, I don't know, maybe x is 3. Oops, I've messed up. Be wonderful if you could use a TI-84 for this, wouldn't it? We're going to drop the 1. 3 times 1 is 3. We're going to add and get -1. 3 times -1 is -3. We're going to add and get 1. 3 times 1 is 3. We're going to add, and we're going to get -33. And I'm just going to kind of stop because that's obviously not going to work. So let's go back in time here. Let's try -3. I'm not going to try any big factors like 15 and 45. Those are just unlikely. Drop the 1, I'll have -3. That's going to be -7. And we add 21. We add and we get 25. This is probably not a likelihood. That's going to be 75. And you can kind of tell it's not going to work. So, okay, cool. Let's try -1. Drop it, we get 1. -1. Add, we get -5. Multiply, we get 5. Add, we get 9. -9. Ah, sweet. -45, +45. There's a 0. So 1 worked. And I've got to find something else because the goal is to reduce to a quadratic so I can do something else. Do remember that. The goal is to reduce to a quadratic. I'm a little bummed that 3 didn't work. Did I try -3? Wish I had a good memory right now, but it's too early. Because I just don't believe that something seems wrong. Well, nothing wrong with it. I just went and checked it. Sometimes when I make things up, I make mistakes. The challenge exam will not have big numbers here. But anyways, since I got my 0, I'm going to do a 5 next, all right? And I'm still going to drop the 1, if this thing will write. Let's get this guy out of the way here. I'm going to drop the 1. 5 times 1 is 5. -5 and 5 makes 0. 5 times 0 is 0. 7 plus 0 is 7. Oh, that's a 9, isn't it? That was a 9. 9, there we go. 5 times 9 is 45, and there's my 0. All right, so now that I'm down to my quadratic, I can switch over to typing. I have x to the second. There is no x, but plus 9 is a 0. I can take away 9 from both sides, and I can counteract squaring by square rooting. Won't look pretty here, but you guys know what the square root of -9 is. I trained you last year on that kind of stuff. It's the imaginary root of a +9, so it's just plus or minus 3i. There's your 4 zeros. Of course you had 4 zeros. It was x to the 4th. All right, factor this guy. This is factoring by grouping. That's all it is. I can pull an x to the second and focus on the first 2 pieces, okay? And then focus on the last 2 pieces. But I can pull an x to the second from the first 2 pieces. There's my alarm. If I pull an x to the second from x cubed, I have an x. If I pull it from -3x squared, I have a minus of 3. And the factoring by grouping technique works in that factor will repeat. And if I pull a +6 from both those pieces, I have it. So we've taken something with 4 things and in essence reduced it to 2, and they both have x minus 3 in common. So that's my common factor that I can pull. And the crap left over is x to the second plus a 6. All right, moving on. We have this on evaluation. Evaluate 64 to the -4/3. And I know how you feel about this, but you're supposed to understand exponential rules. First thing is the exponent is negative. That's your first mistake. All right, this is 1 over. I don't know why I can't ever just, anyways. 64 to the positive 4/3. I don't know what you remember about exponential rules, but judging by the last form quizzes, most of you don't know much. Shame on you. X, well, why can't I? It's so annoying. X to the A over B. I probably used power over R, but whatever. Is the bth root of X all, bad set of parentheses, to the A. All right. So what I have here is I have the cubic root of 64 because the bottom number is the root. Roots are down low. And then I have to turn around and I have to raise it to the 4th power. All right, so what do I have here? I know that the cubic root of 64 is 4. I can do some evaluating. And I have to turn around and I have to raise it to the 4th power. Cubic root of 64 is 4. So 4 times 4 times 4 times 4 again is going to be 256. Ta-da! So 1 over 256. Find the solutions of this guy. Finally, something I can type. You got to have two equations here. One of your equations is written as is, 4x minus 3 less than or equal to 7, because that's how these things work. Or the other equation, negative 4x plus 3, change the signs of both pieces inside, still less than or equal to 7. Let's see what we get here. If we add 3 to both sides on the first equation, we will have less than or equal to 10. Divide by 4, and x is less than or equal to 5/2 because you can simplify fractions. Let's work on the OR guy. We take away 3. We get 4. We divide by negative 4. And when you divide by a negative, you have to flip the inequality symbol. Yeah. So I'm greater than negative 1 or I'm less than 5/2. As an interval, this would look like negative 1 all the way to 5/2. Notice the brackets because I had less than or equal. Brackets and parentheses. All right, term the intervals on which 3x squared plus 10x minus 8 is positive. I'm going to factor this thing. Takes a 3x and an x. Factors of 8 are probably 4 and 2. And what do I want to be in the middle? 10? So plus 4. And then we have a minus a 2. That'll work. And I'm going to set it equal to 0 because I'm after the x-intercepts. That's why I'm doing that. And my x-intercepts, if I use the zero product property, are going to be 2/3 and -4. Now, I notice that a is positive. Since a is positive, it opens up. And it's x squared. X squared is a parabola. So, boy, that's bad. So I'm going to do a quick, really, really ugly graph because I can't draw with a mouse cursor. I got to go back 4. Put a nice little dot there. And I got to go to the right 2/3. Put a nice little dot there. And then I'm going to draw the most hideous parabola you've ever seen. And I'm not worried about the vertex because of the context of the question, which I probably should have explained. You know, what's it mean to be positive? To be positive means that I am above the x-axis. I'm above the x-axis in 2 locations, here and here. Now that left tail that runs left, it is formed by the -4. But the symbolism, since I'm running left, is that I'm less than. That right tail, it happens where x is 2/3, but since I'm running right, greater than. So on your challenge exam, this is probably going to be an interval. You'd say -infinity to -4. Union with 2/3 to infinity. There you go. All right, the graph of a function is presented below. Using the decimal approximations of the local maximum minima, determine the intervals on which the function is decreasing. Decreasing means downhill slope, kids. Ugh. Decreasing means downhill slope. I'm decreasing here to here, from here to here, and from here forever. So this ought to be an easy question. Hopefully you don't miss it. But I'm decreasing from 3 to -2.147, I think. The next interval of decreasing starts at -0.333. And I stop decreasing at 1.397. Union with, the next interval of decreasing happens at 2. And it decreases forever to the right-hand side, so all the way to infinity. Ta-da! All right, so you won't like 9 and 10 because of the notation they're using. And the notation they're using is this guy. AFs of B times X minus H, close, plus K. B is something that's very unlikely to be on your challenge exam, so we're just going to throw it away. All right, so let's think about what happened to this thing. This thing visually has been flipped. I don't know if you can see that or not. But it's been flipped. So A is negative. It's also been moved. This guy is to the right 2, still to the right 2. But something else has happened. It looks like it fell a unit. I say that because of this. I'm looking right here at this dot right here. If it would have been flipped and flipped only, that dot would have been 2 units in the sky. It hasn't, I guess maybe you could think about reflections on the x-axis or whatever, but it's not a reflection on the x-axis, it's just been flipped. And if it just would have been flipped, this is 1 unit lower. So it also fell 1. So the transformation here is negative, that's it, negative f of x minus 1. That's all that's happened to it. I think that might make some sense down here too. Really, really small, but that looks like it's at 6. Whereas before it was at, oh no, it's more than that, isn't it? Forgive me, I'm wrong. So if we flip it and we reflect it, this would be down at negative 2. And we had to add 3. And if this guy was reflected, it would be at negative 9. We have to add 3 to get to 6. So reflected and then shifted up 3. I almost made a big mistake. Part of that's because of how small this thing is. Quadratic has a vertex at negative 5, 3. Determine the vertex of the quadratic after the transformation g of x equals f of x plus 5 minus 10 has been applied. All right, so this guy right here, this x plus 5, that means that we don't shift right, we shift left 5. And then we have the minus 10, which is simply down 10. So if we take our negative 5 and we take away 5 more, we're at negative 10. If we take 3 and we take away 10, we're at negative 7. That's an easy question. Find the domain of this guy. What we're going to do is we're going to think about where the denominator is not 0. X to the second minus 4x minus 5 cannot be 0. I don't know why that's over there, but whatever. And then we're going to factor. That factors is x minus 5 times x plus 1. And again, it cannot, will not be 0. I don't know why I can't do that. Okay, let's just use the equality symbol here. I'll just strike through it by hand. And using your not 0 product property, x is not 5 and x is not 1. Now be prepared for interval notation. We are allowed to be negative infinity all the way to negative 1, union with negative 1 to 5, union with 5 to infinity. All right, find the domain of the root of 4x minus 12. The deal here is for the square root of anything, whatever's inside the anything is greater than or equal to 0. I'm sorry this is taking so long. I'm not at school and it just takes longer to do. So 4x minus 12 has to be greater than or equal to 0. Add 12 to both sides. 4x is greater than or equal to 12. Divide by 4, and x is greater than or equal to 3. Ta-da! Find the difference quotient. This is something that'll be on your challenge exam. It's a given. And it's going to be kind of a pain because I had to type this out. But all you got to do is follow this rule right here. This rule wants you to find f of x plus h. So let's find f of x plus h. That means that every x we see becomes an x plus an h. So you're going to write x plus h twice. I'm going to do the distributive property real quick there. X plus h times x plus h is an x to the second plus 2xh plus h squared. And let's see, we still have the minus 3x minus 3h. We're going to clean that up. We have 2x to the second plus 4xh plus 2h squared minus 3x minus 3h. Now here's the buzzkill for some of you. You're nowhere near done. All you did was figure out that piece. All right? That's all you did. To save time here, well, actually I can just copy and paste. I'm supposed to take away the original function and make sure you wrap. Take away all of 2x to the second minus 3x. And that's all sitting pretty over an h. Now, I have a 2x squared, take away a 2x squared. Gone, gone. I have a negative 3x, take away a negative 3x, which means plus, so gone, gone. This set of parentheses always cancels out, always. What am I left with? I am left with 4xh plus 2h to the second minus 3h all over h. Each of these four pieces has an h, so that h can be divided out. We have 4x plus 2h minus 3, and usually you put the h at the very end. What you actually found is something called the derivative, but it's 4x minus 3 plus 2h. Identify all the asymptotes. This one has 2. Oh, it's got a vertical asymptote. X minus 2 is 0, so the vertical asymptote is x equals 2. And if I just focus on the first pieces, I have x squared over x. I'm looking at a slant asymptote. So I get to do long division. This is going to be bad. For some reason, I can't even use my fingers anymore on this touchscreen. So I apologize for the length of time and what you're about to see, but this is going to be bad. All right, I have to multiply x by x to become x squared. Now use the distributive property. I'll have x squared minus 2x probably going to have to do long division on your challenge exam, kids. I'm going to wrap before I subtract. X squared minus x squared is nothing. Negative 4x minus the negative 2x is negative 2x. and n plus 3. Now, if you're wondering why I'm doing long division, it's because long division always finds asymptotes. Always. Always. To become negative 2x, I have to multiply it by a negative 2. And this is going to be it. There's going to be a remainder. There's going to be some other stuff. But this is going to be it. That is your slant asymptote. It's y equals x minus 2. Long division finds the slanted asymptotes. We had that lesson. Not too long ago either. Function is even and has y-axis symmetry if f of negative x equals f of x. A function is odd and symmetrical about the origin if f of x is equal to f of negative x. Determine whether g of x equals 2x cubed minus x is even, odd, or neither. So I've got to find a couple of things. I have to find f of negative x. That's just part of it. That means that every x you see becomes a negative x. So if I take a negative and cube it, I have a negative. And a negative times a negative is positive. Now, ask yourself, is this equal to f of x? And the answer is no, so not even. I also have to find negative f of x. That means to take the original function and just wrap it in a negative 1 and see what you get. If I distribute that negative, I get negative 2x to the third power minus x. So I say, is this equal to f of negative x? Yes, it is. The function is odd. And the last one, restrict the domain so that f of x is 1 to 1 and find the inverse of f of x equals x minus 3 squared plus 4. And you also need to state the range of both functions. That needs to be added in there. All right, so the domain for the original function, we're going to throw away part of the graph. Remember, this is a shift right 3. We're only going to allow x values that are greater than or equal to 3. That's it. Oh, now I can do the not equal sign. And this is, by the way, is for f of x. The range, well, we have a plus 4, so we start out 4 units in the sky. Think about your mom functions. There's a shift up 4 for mom. Then we rise to infinity. All right. Since the domain has been restricted, I can now write the inverse. And for like the umpteenth time, we swap x and y. We resolve for y. Now we use the correct notation. All right, so this becomes x equals y minus 3 quantity squared plus 4. We're going to subtract 4. X minus 4 equals y minus 3 quantity squared. I'm going to take the square root, and I can't type the square root here, so I'm just going to use the exponent rules. X minus 4 to the half is y minus 3. Add 3 to both sides. And then notation. Now, if you thought about what this thing looked like on a graph, it would be right 4. And it would be up 3. And then it'd be an arm. So when you talk about its range, its domain is still going to be 4 to infinity, the same as the last one. That's because we restricted it earlier. And its range was 3 to infinity. It's just as simple as looking at that 3 there. And that is that. I hope you enjoyed.